Okay, can you hear me?
Hello? Yes.
Yes, okay. How this is did I ask you to try these questions? 4, 5, 6, 7 like that. And you try this, you try the rest. 4, 5, 6, 7. Cannot, then I show you next week. Okay, right. Okay, we continue with the geometric progression. Now, the last week, before we end the lesson, I introduce you to the geometric progression. Now, for geometric progression, when you move from one term to another, you multiply with a certain number. Now, that number can be three types. You can either have a number bigger than okay.
Hello?
There are three types of geometric sequences. Okay, one type is like this, 3, 6, 12, 24. And the number gets bigger and bigger. So how you move from one number to another, you multiply with a number bigger than 1. Then the number will become bigger and bigger. Now you can also multiply with a number, but this time the number is less than 1. Now, if the number is less than 1, then the terms will become smaller and smaller, will become smaller and smaller. Now, there is also another type where you become like that. Let's say we have 2, don't want 2 lah. Okay lah, 2, then negative 6, 12, 12, then negative 24, and so on. Now, for this type of geometric progression, you also multiply with a number. You also multiply with a number, but you multiply with a negative number. So when you multiply with a negative number, the terms, they alternate. One positive, one negative, one positive, one negative. This is also a geometric progression or a geometric sequence. So can you recognize these three types of geometric sequence?
Yes.
Can or not?
Yes.
Yes. So the first type is the number is bigger than 1. So the terms, they become bigger and bigger. Another one, the terms become smaller and smaller, and multiply with a number less than 1. Then another type, the sequence is positive, negative, they alternate like that. So when they alternate between positive and negative, it is also a geometric sequence. But this geometric sequence, you multiply with a negative number. First time you multiply, it becomes negative. Second time you multiply, it becomes positive. That's how it comes like that. Okay, so you remember there are three types. There are three types of geometric sequence. So now we go on with the pattern. This one I've gone through with you, and last week you managed to answer the question. It shows that you understand, right? But anyway, we take this example. So the example is 3, 6, 12, 24. Similar to our arithmetic progression, we call these numbers T1, T2, T3, and T4. So T1 is A is 3, T2 is 6, So how to get 6? You multiply by 2. T3, the 6 multiplied by 2 again, you get 12. 12 multiplied by 2 again, you get 24. But if I just tell you multiply with 2, multiply with 2, you cannot see the pattern. So I break them up. Into the factors, break them out into factors. So T2 is actually 3 times 2. T3 is actually 3 times 2 times 2. Each time you just multiply with one extra 2 there. So T4 is 3 multiply with how many 2's?
3, 2.
3 2's. Let's say if I go straight away to T10, I will have 3 multiply with how many 2's?
9.
9 2's. Let's say if I don't know the term, right? There's a general term that Tn. So it will be 3 times 2 times 2 times 2. How many 2's are there? I have n terms. Nth term, the nth term. How many 2's are there? Will there be n number of 2's? Is it 10?
No.
There will be 9. 4, there will be only 3. So let's say if I have n, how many 2's
And
are
minus 1.
there? N minus 1. So they cannot be n number of 2's because the first one is not a 2. So you cannot have n number of 2's. So it's n minus 1. The first one is a. Okay? That's why you have to take care of the first one. So there's one less. So it's n minus 1. Okay, now similar to our arithmetic progression, for geometric progression, the number that we multiply is not called the common difference. It is called the common ratio. Now, usually the common difference, we take the term behind minus the term in front, then we get the common difference. For common ratio, you take the term behind, divide by the term in front. The term behind divide by in front, right? So 6 divided by 3. 6 divided by 3. Or you can use 12 divided by 6. 12 divided by 6. So that number is actually 2. That number is 2. So the common ratio is called, for this question, the common ratio is actually 2. The common ratio is actually 2. Right? So how to get 2? You take the term behind, divide by the term in front. Right? So from there, you know, let's say if you want to have Tn, the first number will be A. The first number will be A. And the number behind will be R. But how many R are there? N minus 1 R. So we have this formula. The number of the term, the formula for the term is AR to the power of N minus 1. Okay, so you have to remember this formula, AR to the power of N minus 1. Now, for this common ratio, how to find the common ratio? You take the term behind divided by the term in front. The term behind is n, the term in front is n minus 1, right? Okay, so like that. Okay, so you take the term behind divided by the term in front, you will get the common ratio. Okay, we look at this question here. Find the given term in each of the following geometric progression. Okay, so let's say this is I show you example B, right? Example B. So you look at this example B, this one, B. 16 over 27, 9 over 8 over 9, 4 over 3. So they tell you this is a geometric progression and you have to find the T6. T6 is the sixth term. Before you continue to find the sixth term, you have to find out two things. What are the two things? Number one is the A,
A
number two is
and
the
R.
R. So you have to find the A and R before you can find the term. So this number here, the A is 16 over 27. So A is 16. If I want to find the R, I take the number behind, 8 over 9, 8 over 9, then divide by the number in front. Number in front is 16 over 27. So 8 over 9 divided by 16 over 27. So 8 over 9 multiplied by 27 over 16. So you have 3 over 2. Before we proceed, I ask you, this 3 over 2 is bigger than 1 or smaller than 1? Yes? Bigger or smaller than 1?
Bigger.
Bigger than 1. So if it is bigger than 1, what do you expect the sequence to be? The sequence become bigger and bigger in value, or the sequence becomes smaller and smaller in value, or the sequence alternate positive, negative. Which type is this? Bigger and bigger? Smaller and
Bigger
smaller?
and bigger.
Huh?
Bigger and bigger.
Yeah, it becomes bigger. So you must recognize whenever you find out the R, you must recognize that, oh, this one, my mind start to work. This is R is like that. It must be bigger and bigger. The R is bigger than 1. The term must become bigger and bigger. These things you have to start to think. No, we are not going to tell you. Right. So now they want to find T6. T6 is use the formula what? A R to the
AR
power of n minus 1.
and 1.
What is A? A we found out already. 16
16
over
over
27. What is R?
3
3
over
over 2.
2.
What is the n minus 1?
6 minus 1.
6 minus 1 is 5. Now this one, if your mathematics is not good, you cannot remember the numbers, you use the calculator. Do you know how to use the calculator to calculate this?
Yes.
Power of 5 is that one. Then 5.
Mm.
That symbol like that, like a cap like that. So then power of 5. So you know how to type, and you get this. Now this is given in your, this question here is given in your lecture notes. You read number 1 and see.
Given a geometric sequence have a first term of 3 and a common ratio of 2. Write the first 6 terms. Find the 15 terms.
Okay. So I tell you what, number 1. Okay, we try the questions given. Number 1. Okay. You say what? First term. First term.
A is 3.
A is 3. Okay. A is 3. Then what else?
R is 2.
R is 2. Okay, the first term is 3. Then next one. How to go to the next one?
Times 2 times 2.
Times 2. Times 2 become 6. We want 6 terms. Next one?
Ah. 12.
12. Next one?
24.
24. Correct then?
48.
48 then? One more.
96.
96. Okay, so this is our geometry. Find the 15th term. So they want to find what? What the symbol 15th term is what? The symbol?
T15.
15. What is the formula for T15?
3 n minus 1.
N minus 1, okay. What is A? 3.
A 3 3 to 14.
2 to the power of 14, huh? To the power of 14, correct. Can you use your calculator to count? I don't know. Very big number. What did your calculator say?
49152.
4, 5,
9152.
9, 1, 5, 2. Is it 4, 5? Here. Is it 5? 4, 5. Or
Ah,
straight? 4,
49152.
no 5, ah?
No 5.
No 5, huh? 49152. Okay, right. So this is number 1. Then number 2, you read number 2.
Find the eight. Find the eighth term of the geometric sequence whose first three terms are 9, 3, and 1.
Can you tell me what type of R is this? 9, 3, 1.
Smaller and smaller.
Smaller and smaller. So what is the A?
9.
9. What is the R? You know already. You have predict.
3/9.
3 over 9 is
1/3.
1 over 3. So can you find out what is the T8? So I leave this to you to find what is T8. Can or not?
Mm.
You can find what is T8. Okay. Okay, what's T8? Then this one cannot really. The sum of first n terms. Wow. Okay, so cannot this one, cannot really. So I have to tell you the sum of first n terms. Okay, tell you the sum of first n terms. Next one. Oh, there are a lot of tricks over here. There are a lot of tricks. Before we find the sum of n terms, there are a lot and a lot of tricks. Oh. Okay. A lot of tricks there. A lot of tricks. Okay, so we're going to choose one, 2B. 2B. Okay, this is 2B. Now, can you tell me what is the A?
A.
How much is the A?
5.
5. How much is the R?
25/3.
You use your calculator. 5 over 3.
1/3.
1 over 3, correct. So you know the A, you know the R. Then they say there is one term there at the back there. 5 over 729. And they want to know how many terms are there. So normally, the last one you don't know, what must you do? You call it what? The last term?
Tn.
Correct. You call it Tn. So now the A is 5, the R is 1 over 3, and we call the Tn, this thing 3, Tn, we call this Tn. Now Tn is A, R, n minus 1. Okay, when you divide by 5, then it's 1 over 729. So far, okay or not until here?
And
Not okay, then I explain again.
Can.
Can. This is Tn, right? This is Tn. So I use the formula equal Tn. The 5 and 5 can cancel away. So here no more 5. Here also no more 5. Now the problem is this thing, n minus 1 is this thing. Now, of course, if your knowledge of mathematics is very good, wow, straight away I know this n is what number, 729 is 3 to the power of what? But then we cannot memorize so many numbers. How are we going to know this 729 is 3 to the power of what? There's something that you can do. You can make use of logarithm to help you. The logarithm is the previous chapter, right? But even if you don't know logarithm, you just take log on both sides. Okay, you take log on this side, take log on this side. You see, whenever there's a power that is unknown, you take logarithm. You know what is power or not? The index, the base, the index, the small subscript number at the top. So that number is called the index. If the index is unknown, you take log. This is the technique that we are going to use for solving problems. If the index is unknown, you just take log. Now, when you take log, according to the law of logarithm, this index you can put in front already. This index you can put in front. Okay. If you don't know logarithm, never mind. You just remember the steps. Okay or not? You just take log, then the number at the top, then you put in front. That solve everything already. So when you take this number at the top, you put in front, this log of 1/3 is actually a number. This log of 1 over 729 is also a number. So you take this number, divide by this number, you will get n minus 1. Okay or not? Take the log on the left-hand side, which is actually a number. Then the log on the left side is also a number. So you bring the log over and you get logs 1 or something. Do you know how to type this inside your calculator?
Yes.
You type log, then bracket, then 1, then the ABC, 729. One more time. You type log, LG, LOG, inside your calculator is LOG. Then you put bracket, the open bracket first, 1, then the ABC there, then 729, close bracket. Okay, now? This line here means divide. So you press the divide button. You press the divide button, then you type log, then 1, ABC, 3. Must put bracket. Tell me what is the answer?
6.
Answer is 6. Correct. So this n minus 1 is 6, so n is 7. Cannot? Okay, so good. So now you know you have to do this one 4, 5, 6, 7. If you don't know, you just let me know. I'm going to show you. And you also do this one 2A and 2C. 2A and 2C. Okay or not? Okay. Then 2A and 2C, right? So now we proceed to another type of question. You read question number 3.
If p minus 3, p minus plus 3, 4p plus 3 are 3 consecutive terms of a geometric progression, find the possible value of p and the corresponding value of the common ratio.
Okay. Now, here they are talking about 3 consecutive terms in a geometric progression. You seen something like this before in arithmetic progression or not? 3 consecutive terms in a geometric progression. Okay. The 3 geometric arithmetic progression, you take the number behind minus the number in front. It will give you the common difference. Then you take another pair, the number behind, you minus the number in front. It is also the common difference. So these two numbers, they are actually the same because they are common difference. So you form one equation. For arithmetic progression, you take the number behind, divide by the number in front. For geometric sequence, what must you do to find the R?
Divide.
You divide. Okay. So now, let's say if A, B, and C are three consecutive terms in a geometric sequence, A, B, and C So you take this C divide by B, you will give you the R. You take the B divide by the A, it will also give you the R. I don't know what is the value of R, but I know this must be equal to this because the two of them are R. So that means I know B over A equal to C over A. Any questions so far?
No.
No. But if it's for arithmetic progression is C minus B equals to B minus A. It's minus, but geometric. Okay. Now we look at this question number 3 again. So I take this 4p plus 3 divide by p plus 3 equals p plus 3 divided by p minus 3. So this is b over a, c over a. Any question?
No.
No. No, then you must know how to solve this quadratic equation. This factor at the bottom, you move to the other side, they go to the top. So you have two similar factor. This factor at the bottom, you move to the top, and you have two factors like this. Okay or not? Okay. Then we continue. I expand this like our binomial expansion, You remember binomial expansion? You just expand this one. This one also, you expand. But this one, not a binomial expansion. This one, you have to expand slowly one by one. And after that, you move all to one side to form a quadratic equation. This quadratic equation you will do in mathematics, Form 5 or Form 4 like that. This one, quadratic equation. I think Form 3 they learn quadratic, they have to factorize. Right? So you divide by 3, divide by 3, divide by 3, then you get a very simple quadratic equation. So using trial and error, you have to factorize the quadratic equation. I don't know, do you know how to factorize quadratic equation or not?
Yes.
Yes, if you don't know how to factorize, you refer to the calculator. The calculator can do for you. They just straight away give you the answer. P is -1, P equal to 6. Do you know how to use the calculator to get the answer?
Yes.
Yes. Okay, so answer already, they want the value of P, right? So find the corresponding common ratio. So the common ratio, you have to divide or take the term, divide by the term, right? P found already. So if P equals to -1, P equal to -1, I put back here, -1 minus 3. What do you get?
Yeah.
I take this -1, P -1, then I put inside here. P minus 3 is -1 minus 3. What do you get? -1 minus 3.
-4.
-4. Then I put here, -1 plus 3. -1 plus 3.
2.
2. So I get 2 here. Then I put -4 plus 3. I get -1 here. So when I take the value of P and put back, they form a geometric sequence. They form a geometric sequence. The geometric sequence is like this. So from this geometric sequence, can you find the value of R, they say? Can or not?
Yes.
Yes, so you can find. So you find the value of R. But that is for one value of P only. Then you have to take this 6, you put back inside here. P minus 3 is 6 minus 3. What is 6 minus 3?
6 minus 3. 3.
Then I put that 3 lor. The first term is 3. Then I put 6 here. 6 plus 3. P plus 3 is 6 plus 3. How much is it?
9.
9. So I put down 9 there. Then if you put there 6, 24. 24 plus 3, 27. So if you look at the geometric sequence, you divide the behind with the front, you get the value of R equals to 3. R equals to 3. So geometric is difficult because there are many tricks. Like you have to do quadratic equation, you have to use the log. So you go through what I've taught you here, the tricks, right? 3 consecutive term, then how to use the log. Okay. Then okay. Then I see what is next first. Next one. Next one, they have to form equation and solve. This one also got some technique. I have sent you this already, right? So that one later I show you the next lesson. So you do how many more? 1